Welcome to Theory of Computation class. Today I am going to discuss about Unit-4, which contains simplified context-free grammar and Turing machine. The first part of the fourth unit is the normal form notations. There are two normal forms are available. One is Gribach normal form and another one is Chomsky normal form. For conversion of a context-free grammar to this normal form, first step is we should simplify a context-free grammar, which contains 3 steps in it. So, in today's class, I am giving the problem for solving the simplified CFG notations. Then the normal form will be discussed in later class. And the second part of Unit 4 contains a Turing machine. And few problems are available in it. So, this will be discussed in future class. Today, this topic is a simplified CFG notation. So, if you want to construct a normal form, the first step is we should eliminate 3 notations from a given context-free grammar. For this elimination of those notations is called as the simplified CFG notation. So, we can able to construct a normal form only from a given context-free grammar. So, an extension of the context-free grammar is a normal form notation. So, if you want to construct a simplified CFG formation, step 1 is we should eliminate epsilon production in a given context-free grammar. So, is there any epsilon production is available? First, we should eliminate that production. Then after that, we should eliminate unit production. Unit production means a non-terminal. This is a production. A implies B, where A and B both are a non-terminal symbol. So, if a production contains only one non-terminal at its right side, then it is called as unit production. So, these type of productions also be eliminated from a given context-free grammar. This is step number 2. And in step 3, we should eliminate useless symbols. There are 3 different cases are available. First notation is an elimination of epsilon production. For example, here there are 2 productions are available in a given CFG. One is X1. X1 contains 2 productions in it. One is W, X1, X2. And the second production is X2 implies epsilon. So, if you separately write those productions, X1 implies W, X1, X2 and X1 implies epsilon. So, I write those productions separately. And the third production is X2 implies epsilon. And this problem is elimination of epsilon production. So, we should eliminate the second production and also the third production from the given grammar. So, how can we eliminate means? This is the non-epsilon production, in which we should substitute X1 as epsilon, X2 as epsilon. For example, the given production is X1 implies W, X1, X2. This is the first production. And second one, I rewrite it. I substitute X1 as epsilon at its right side of the production. So, if you substitute X1 as epsilon, epsilon is an empty symbol. So, W epsilon X2 is only W X2. And the left side of non-terminal is X1. So, we can able to rechange the first production as like this. And if I am substituting X2 as epsilon here, only I am substituting X2 as epsilon. X1 is as it is I am writing. So, the answer is W X1. Because if I am substituting X2 as epsilon, the end is epsilon. So, it is W X1, the left side is X1. And third time, if I am substituting both X1 and X2 as epsilon, only W is available at right side. So, this is a generalized notation and these 3 are the modified substitutions of epsilon for the X1 value, X2 value and both those values. So, these 4 are the elimination of, after elimination of productions format. So, this is the elimination of epsilon production. Okay, for example, I am taking a problem as A implies small a capital A bar epsilon. Eliminate epsilon production. The question will be asked as eliminate epsilon production, otherwise implement a simplified CFG for the given grammar. So there are two productions are available, so I write it separately. The first production is A epsilon epsilon and second production is A implies epsilon. In the first production there is no epsilon format is there, so you just write that production as it is. So this is after eliminating epsilon. So after eliminating epsilon, the first production is as it is, we can able to write it. And this is the second production contains epsilon in it, so it cannot be included in after eliminating epsilon notation. So first time I should substitute the first A symbol as epsilon. So the notation is only A and the second symbol epsilon. And if I am substituting, I write the first A as it is and I substitute the second A as epsilon, means the same production is available. So if the same production is occurred, you can write as it is. So already I write the second production for substituting the first A as epsilon. The same answer will be occurred for the second one. And in the third time, I substitute both A as epsilon, means only right side small a is available, left side is A. So these three are after eliminating epsilon. You can either able to write separately or you can combine like this. That means you can combine those three productions in a single notation with slash symbol. So this is the after elimination of epsilon notation. Is it clear? Then I give the second example. So second problem is S implies small a capital S small a, small b capital S small b bar epsilon. So I write it separately. S is A is A and the second production is B is B. Third production is epsilon. So you can write the first two productions as it is. So after eliminating epsilon, so the first production is as it is. Second production is also available. You cannot able to write the third production. So instead of that, I substitute epsilon as S in first production. So the first production will be rewritten as small a, small a. If I am substituting epsilon at second production, it will be rewritten as S implies small b, small b. That's all. So these four are after elimination. So either we can write as it is, otherwise you can combine all those productions, because all four productions contains left side common symbol as S. So I can able to write it as A S A or B S E or AA or BB. So this is the answer for elimination of epsilon production. Okay, thank you.